Namaskar, my dear friends. So we'll see today one of the best microcontroller, which is PIC18F47Q10. Okay. So this is our target device. Our target device will be again 40-pin PD package. This is DIP package. Okay. There are more packages, like this is my 44-pin TQFP package, and this is 40-pin QFN package. Okay. So we have 40-pin and 44-pin. PIC18F47Q10. What we'll try to understand is, this is a very new device. This is very popular from Microchip Technology, and we'll try to understand what is the features and functionality that this microcontroller is supporting, and we'll see a target application for this particular device 40-pin PD package. Okay. So there are a lot of case studies with our clients, and they have been using it for so many projects, or even automotive projects, as well as home appliances and industrial applications. So I will try to spend some time in one of the case study that we had taken in our last clients, and we will see how it is very much useful for them. So let us try to understand. This is the product page. Once you open, you will be able to see this particular page. So it is recommended for automotive design as well. Okay. And you will see PIC18F47Q10. This is a particular series. There is one more which is F27Q10. So F47 and F27. So 27 is actually 28 pin, and 47 is 40 pin and 44 pin. That is the availability. Okay. So let us see some of the features very quickly. So as you can see, it has 83 instructions and 31 stack labels. Okay. It is coming up with 64 megahertz oscillator. It can operate, like 1.8 volt to 5.5 volt. So I'll recommend you use for 5 volt application or 3.3 volt application. But I will be giving you an application circuit which will be operating with 5 volt application. Okay. There are two temperature ranges. One temperature range is -40 to 85 degrees centigrade, and one more is extended version which will be -40 degrees centigrade to 125 degrees centigrade. So most of the cases, this particular temperature range will be enough, but for other purposes you can go ahead with -40 to 125 degrees centigrade. Okay. Now it has 128 kilobytes of flash memory. Okay. And it has 3728 bytes of SRAM. Okay. So it has flash memory, SRAM is there, and even EEPROM is there, which is 1024 bytes, that is 1 kilobyte. Okay. Now it has ADC with 10 bit. So there are almost 35 channels are there. So you can see, out of 40 pins, 35 pins are capable of driving your ADC. Okay. So any pin you can consider that will be having a capability of ADC functionalities. Okay. It has 8 cross configuration logic cell. Okay. So you can configure the pins into configurable logic cells. It has one 5-bit DAC as well, digital to analog converter. It has two comparators. It has fixed voltage references. So fixed voltage reference, you can see there are a lot of like possibilities. That is 1.024 volt and 2.048 volt and 4.096 volt. Okay. So if you are working for 5 volt application, I'll recommend you to set your voltage reference with 4.096 volt. And if you are working for 3.3 volt application, then you have to utilize 1.048 volt. Suppose your ADC values ADC analog voltage is very less, then you can set the lower voltage as well. Okay. Now we have hardware capacity voltage divider. This is very good functionalities. I will come across this during our application design. Okay. And we have zero cross detection. We have I2C SPI communication interfaces. We have UART. Okay. It has a capability of supporting link protocol as well. Okay. So you can see it has almost all kinds of communication interfaces. All right. Like I2C, SPI, UART, and UART with Lin support as well. Got it? If you see, we have a cyclic redundancy check with memory scan. Okay, so CRC is there. We have windowed watchdog timer. We have HLT, that is hardware limit timer. We have complementary waveform generator. So this CWZ functionality is having very good, applications. Like you can generate your waveforms. Let's say you want to generate your sawtooth waveform, or you want to generate, like a square waveform, or you want to generate like sinusoidal waveform. So any waveform you can generate with this particular uh, waveform generator. All right. Now we have 10-bit PWM modules. Okay, so you have two PWM channels on which you can generate your PWM signal. You have two capture, compare, and PWM modules as well separately. We have 8-bit timers and four 16-bit timers. So you have ample amount of timers that you don't have to worry about for particular, like microcontroller. So this is very good microcontroller, very sturdy and very strong microcontroller, which is being used very popularly from Microchip Technology. All right. And as I mentioned, we have extended watchdog timer and all these things that we have already written. We have other functionalities, that is DAWs mode or ideal and sleep mode. So this modes you can put it for getting the microcontroller into power saving modes. So suppose the microcontroller is not in the function, or your unit is sitting idle, then you can enter the microcontroller into sleep mode so that it doesn't consume power. All right. So this particular microcontroller can be used for your battery operated systems as well, because it is 8-bit microcontroller, very low power consumption microcontroller. Now it has low current power on reset. It has Brown on reset as well, like BOR. It has low power BOR as well. It has peripheral pin select that we'll be talking about. Let us say you will be having a trouble of, let's say, I2C functionality, which is SCL and SDA lines. Okay, so this SCL and SDA lines can be assigned to any pins if it has a capability of PPS. Okay, peripheral pin select. All right. So this is remappable pins, like any pins which is having a capability of PPS, that can take a functionality of either I2C or SPI or UART, any of the one, I mean, parameters that it can take. So that table is there in the data sheet, which can tell you which functionalities can support, right? And it has the capability of in-circuit debug integrated on-chip and ICSP programming. So we will be seeing this ICSP programming. All right. Now let me give you a functionality of like how it can be programmed. So basically we will be using a programmer which will be MPLAB X ID. So MPLAB X ID is more than enough, which comes up with a code configurator as well. Okay. So this is called MCC. So MCC is inside this, like integrated into MPLAB X IDE. Okay. So this development environment is having code code generation as well as uh, code development also. Okay. And this is PIC18 programmer debugger that you can connect. So we will be seeing this programmer as well as ICD5 programmer connector, how we can connect the microcontroller with the programmer. Okay. So this is my MCU and this is my programming connector. All right. So this is how it will be programmed. Got it? So let us directly go into the data sheet and we'll try to see all the features in detail. So let me directly open the data sheet and we'll see the features there. Got it? So this is our data sheet which says it has the capability of 28 pin, 40 pin and 48 pin configurations. And this is the part number, which is PIC18F4747. 27 is one series and 47 is another series, Q10. So let us move to core features. So as you can see, it has C compiler optimized. Okay, it has capability up to DC2 for 64 megahertz clock. So that we already saw. It has minimum instruction cycle, which is 62.5 nanoseconds. Okay, It has programmable 2 level interrupt priority. It has 31 level deep hardware stack. So if you are going to develop a like a circuit design, or like develop a application based on this particular microcontroller, you need to be familiar with each and every lines of the features that this particular microcontroller supports. All right. So we have already seen, like, it has 3 8-bit timers, 4 16-bit timers. It has low current power on reset. It has power up timer. It has brown on reset, low power brown on reset. It has WWDT. Okay. So let us talk about core features is fine. We'll talk about memories. So memories we already saw just now, that it has 128 kilobytes of flash memory. It has 3615 bytes of SRAM. Okay. And it has 1 kilobyte, that is 1024 bytes of EEPROM. It has programmable code protection as well as direct, indirect, and relative addressing modes. Okay, so this addressing mode will help you to write the program better. Okay. Operating voltage range, you can see that it can work from 1.8 volt to 5.5 volts. This is very good, like operating range. So this is very good for 3.3 volt application as well as 5 volt application together. So I'll suggest you which is the application which are having very robust and very like a sturdy, those can be utilized with 5 volt application very easily. All right. So 5 volt application we will be anyway seeing in our application. And as I already mentioned you, we have the temperature range -40 degree to 85 degree centigrade, as well as the extended temperature which can work up to 125 degree centigrade. Got it? Now you can see we have power saving of operation modes. So we have DOS, like the microcontroller can go into DOS mode. Okay. It has ideal operation. It has sleep cycle. It has peripheral module disable mode. Okay, so you can disable also. Then it has extreme low power mode, that is XLP. Okay, so XLP, you can see that it takes just 500 nano ampere at 1.8 volt. Got it? And if sleep and watchdog timer is enabled, then it will be taking 900 nano ampere. So it is going into nano ampere range. Okay. Now we had seen closely just now that what were the digital peripherals. So digital peripherals, we have CLC, that is configurable logic blocks. We have CWG, that is complementary waveform generators. Okay, which can tell you like rising and falling edge, dead band control. Then we have full bridge, half bridge, and one channel drive. We have multiple signal sources. So I told you already that it can generate like a square wave, sinusoidal wave, or triangular wave. All those things you can generate. Got it? We have capture, compare, and PWM. So two capture, compare PWMs are there. Okay, it has 10-bit resolution for PWM modes. Got it? So it has two 10-bit PWM separately, and there also two. So total 4 PWMs you can generate. Okay. Then we have serial communications, like enhanced UARTs are there. Okay, and it has RS-232, RS-485, and lean compatible. So you don't have to like utilize a separate RS-232 converter. The same line can be able to do that job. Okay, then it has SPI, I2C, and SM bus, PM bus compatibility. So all these particular like serial communication is very very powerful and very easy to implement. That we'll see in our application design circuit. Got it? Okay, we have around 35 input output like GPIOs basically. And we have individually programmable pull-ups. So programmable also, you can pull them up. Okay, you don't have to add a separate pull-up outside the microcontroller. Got it? Okay, so everything is fine. I think you guys are getting almost everything that I am telling you right now. Once you are familiar with the microcontroller completely, it will be easy for all of us to design it very easily. All right. Moving to the next thing, we have programmable CRC with memory scan. So already we have seen that. We have hardware limit timers. Okay, so that also we have seen. Then we have peripheral pin select, which can map any digital IOs to a different functionalities. As I already mentioned, that many of the pins can be like given a functionality of I2C, SPI, or UART, all those things, okay, or SM bus or PM bus. So all this functionality it can be given. We have data signal modulator as well. Now let us talk about analog peripherals. So analog peripherals, as I already mentioned you, we have 10-bit analog to digital converters, okay, with computation capabilities as well. And we have total 35 external channels. We have 4 internal analog converters, okay. So analog channels are there, 4 internal. We have internal and external trigger option is also there. We have very good functionality which is having automatic math functions, okay. So in this you can do averaging, filter calculation, we have oversampling capabilities, we have threshold comparison as well. Now one more thing that you will be seeing later on is hardware capacitive voltage divider support, okay. So in this capacitive voltage divider support we will be seeing some applications where it can be utilized, okay. We have guard ring digital output drive. We have zero cross detection where it is very much used in like AC signals on pin cross ground when pin crosses the grounds. Then we have digital to analog converter as well. So this very small microcontroller is having ADC, DAC, everything, and as well as it is having very strong physical capabilities as well. Physically it is very strong, so very easy to handle. It has two comparators, okay, and it has fixed voltage reference that I already mentioned, 1.024 volt and 2.048 volt and 4.096 volt. Let us talk about clocking structure. So how clocking is there? So clocking, you can see it has high precision internal oscillator block, okay. So it can take up to frequency of 64 megahertz with plus minus 1% calibration, okay. It has low power internal oscillator also, which is 32 kilohertz oscillator, which will be used for your RTC application, real time clock application, okay. It has the capability of external 32 kilohertz crystal oscillator as well as external high frequency oscillator also, okay. So if you don't want to use your internal oscillator, you can connect external oscillator, external crystal oscillator for clock generations. It has fail-safe clock monitor. It has oscillator startup timer. Now coming to the programming part. So programming part, if you see, it has the capability of like in circuit serial programming, that is ICSP programming with two pins, that will be ICSP data and ICSP clock, okay. So this we will see how to connect these particular signals with the programmer connectors. Now if you see, we have insert the ICD programming also. So in the programming method I told you PIC18F, right, PIC18F and ICD programmer, so both of them can be utilized for programming this particular microcontroller. Got it? Now if you see, we have the family. So family, if you can see, it has PIC18F27. So 27 is basically the 28 pin microcontroller, and 47 is basically 40 pin and 44 pin microcontroller. Got it? And you can see in this particular table almost all these things are summarized together. Got it? So let me give you an insight of this, what is happening here. It has 120, let's say down one. Our target device is PIC18F47Q10. Okay, so down one you see. So down one, if you see, we have programming flash is 128 kilobytes. We have SRAM is how much? 3615 bytes. We have EEPROM 1024 bytes. We have IO pin 36. Out of 36, 35 are capability of ADCs, as well as one is input pin. Then we have 16-bit timers, 4 are there. Then we have 2 comparators. We have 10-bit ADCs, 35 as I already told you just now. We have DAC, one DAC is there, 5-bit DAC. We have zero cross detection 1. We have capture compare and PWM, and 10-bit PWM are there, 2 and 2. Okay, so total 4 can be there. We have CWG, that is a complementary waveform generator. We have CLC, okay, configurable logic cells are there. So configurable logic cells are very useful, and it has total number of 8 pins are there. It has low voltage detect, okay, 1, and then it has 8-bit timer, 3, and it has windowed watchdog timer, yes, it is available. We have CRC with memory scan, and we have extended UART, it is there, 2 are there. We have I2C and SPI, 2 are there. We have peripheral pin select is there, and we have peripheral module disable is capability is also there. We have temperature indicator, as well as we have debug capabilities in internal, okay. So this is I means internal. All right, guys, so I think you guys are now okay with the family, with the family type, and we have the packages. So let me give you the packages immediately. So packages, if you see, we have the SP DIP, that is DIP package, that is 28 pin package. So if you see 27 series, it has SP DIP package, SOIC package, SSOP package, and QFN package, as well as VQFN package. Okay. Now, if you see 47 pin package, then it has TQFP and PDIP and QFN. So I'll suggest you we will go ahead with later on TQFP, but right now our aim is to uh, develop a application with PDIP package, which is 40 pin PDIP package. Okay. All right. So I think you guys are good to go ahead. Like we have seen the overview of this particular microcontroller, and what are the core features that is there with us, what is the pin availabilities, and how what are the different features that is particularly available with this particular microcontroller. So in our next session, what we'll do is we'll try to understand what are the different pin configuration and their pin descriptions. Okay, so pin description, pin configurations, and overview, and what are the minimum requirement for connection of the pins, so that our microcontroller works properly. All right, and after that we will see a live example, or we'll see a complete development of a microcontroller with various peripherals, like how we can connect LEDs, or lot of things. Let me give you an example, a blink of that, or a taste of that is basically we'll try to understand how we can generate our power supply design, then programming, reset, push buttons, dip switches, LEDs, SPI, I2C, UART, and parallel slave port data communication, LCD interface, timers, PWMs. Okay, so various things we'll see, and inside this only we will all see how we can connect our EPROMs. Then we can connect our so many so many sensors, ADCs, and UART to USB bridge, UART to RS232 converters. All those things we'll see one by one. Okay, so good. Uh, Hope you guys are okay with this particular introduction. So once this is fine, if you have any questions or any particular requirement that you want me to complete here, you can put your comments in the comment box, and we'll be able to help you out. Thank you so much.